Okay, good morning, everybody. Welcome back. Well, today we're going to continue talking about circles, and I've got three things I'm going to quickly run through here with you guys and look at a couple examples of. We talked last week mostly about vocabulary, just what is a tangent line, what is a central angle, what is a chord, all those types of things. And this week we're going to get into measurements. So given these different specific lines, arcs, and angles in a circle, and given certain measurements, can I find other measurements? The first thing I wanted to quickly cover here was tangent lines. Now, I apologize, I should have talked more about this last week. I talked about what a tangent line is. It's a line that intersects a circle at exactly one single point. But what I neglected to talk about is that if you take that point, what's called the point of tangency, and you draw a line from that point to the center of the circle, essentially draw a radius from that point to the center of the circle, that radius and this tangent line will always make a right angle. And I would have a right angle here, and I would have another right angle over here. And that's really nice for solving certain types of problems, because I could take, maybe some other point out here, let's call it point S, and maybe I connected these points together. And if I knew what the radius of the circle was, and I knew what the length of this line segment was, I could figure out the length of segment PS, because I can now just use the Pythagorean theorem. And I can use the Pythagorean theorem because I know this is a right angle, and therefore I have a right triangle. And of course I would do 5 squared plus 12 squared equals x squared. And I promise you that you will get x equals 13 here. Okay, so when you see a tangent line, what I want you guys to be thinking of in these diagrams is that the radius that connects to that point of tangency will always make that nice right angle there. Okay. Next thing. So the big topic for today is actually going to be looking at angles and what are called arcs. So we talked a little bit about central angles last week. And I want to remind you guys just what a central angle is. Say I have a circle, I have the center of the circle, and I draw an angle in, or construct an angle, where the endpoints of the angle are on the circle, and the vertex of the angle, excuse me, the vertex of the angle is on the center of the circle. This is called a central angle. What we're going to add to this today, beyond just the definition of a central angle, is how we determine this measurement. And specifically, we're going to start to talk more about this out here, this arc. All right. So any piece of a circle is called an arc. Now, there's two ways that we can measure arcs. Arcs can have what's called a measure, which is, we're going to see, is in a number of degrees. We could also figure out the length of this arc, like the actual distance along this curve. That's something we'll talk about later. We're not going to do that today. What I'm concerned with is how many degrees out of the total possible 360 degrees, how many degrees is this arc? The way we figure that out is actually by looking at the central angle here. And this is kind of our first big idea for today, is that whatever the measure of my central angle is, that turns out to be the same as the measure of the arc that it intercepts. So for example, if I had this same picture, there's my central angle, point A, point B, point C, and someone told me that this angle right here is 75 degrees. I would automatically know that this arc, AC, from this point to this point, also has a measure of 75 degrees. And the way we would write that is we would say the measure, lowercase m, of arc AC. So we use AC and we put a little arc over the top. The measure of arc AC is equal to 75 degrees. When we have a central angle like this, not only do we know the measure of this, what we call a minor arc right here, we now actually also know the measure of this large major arc over here. Okay, now to name a major arc, remember we need 3 points. So I'm just going to throw some other point over here. We'll call it point D. And so we'll call this major arc ADC. So the measure of arc ADC is equal to, well, if this minor arc is 75 and the entire circle is 360, I can take 360, subtract the 75, and that would give me the measure of my major arc. So 360 minus 75 is 285. So there's the measure of arc ADC. All right, and so we can see that this is a very handy tool we can use when filling in missing angles and missing arcs. So here's an example problem. Maybe I have this here where I'm given this diagram, and maybe the instructions say find all the measures of the missing angles and arcs. One thing to note here is that when you guys are working on these circle diagrams, if something looks like a diameter, we can assume that it actually is a diameter. That's something we're allowed to assume in geometry, is that straight lines are in fact straight. So that helps us here. Now right away I can see I have some central angles 78 degrees, which means this arc out here is also 78 degrees. If this is 36, so is this arc out here. Now this angle right here that's missing, we can figure that out because we know this is a diameter. The diameter is going to cut the circle in half, meaning that half the circle is 180 degrees. Well, I know that's 78, I know that's 36. So we could take the old calculator and let's figure this out. So 180 degrees minus the 78 minus the 36, and we get 66. So now I know that this central angle right here is 66 degrees, which means this arc that it intercepts is also 66 degrees. And now using this same technique, I can fill in other angles. I've got vertical angles here. If this is 36, then this must be 36. Again, we can assume this straight line is a diameter. So if that is 36, then this arc is 36. And again, if this whole thing is a diameter and this is 36, let's subtract 36 from 180 and we'll find the measure of that arc. So 180 minus 36 and we get 144. If this central angle is 144, then this arc that it intercepts is also 144. So this is a very simple yet very handy little relationship between central angles and the arcs that they intercept. The degree measurement of each will be the same. All right, so that's going to conclude video number 1 here. I am going to make a second video talking about something called inscribed angles, so watch that one next. All right, see you soon. Have a great week.